Well, here's our next contestant in the Mitsubishi series. It's the Mitsubishi DA P20 dual mono stereo preamplifier. So once again, keeping in the spirit of how the amplifier was, the preamp is also a dual mono design, and so you can see all the controls are separate and so forth. And as far as I know, that other than just needing the pots cleaned and a general cleaning, and possibly we'll do a recap of it because we recap the amplifiers, this one works well. Now this is a unique preamp. I kind of like it in some ways. One thing I never liked, it's just a personal preference of mine, is I never liked when they had separate bass and treble for right and left channel. Although, you know, kind of driving the point home that it's dual mono, that's one of the reasons they have this. However, there's no reason you couldn't gang the potentiometers on top of one another so one shaft rotates both of them. It makes it a little easier. If you want to adjust your tone controls, you kind of have to adjust them both individually. But again, that's just a personal preference of mine. Anyway, this is a really nice preamp. Number one, it's built like a tank. It's very solid. It has what looks to be a pretty nice phono stage. So any of you folks that are really into vinyl, this thing can do both the moving magnet and moving coil phono cartridges, which is a real bonus. It has once again, the speaker interface switches, I'll call them. And if you have that special cable again, like I showed you on the power meter module, you can actually connect it from here to the amplifier, and then this will control the speaker select relays inside the amplifier, just like the power module does. The only kind of strange thing I noticed about these whole setups is you can only really attach one item to the amplifier, and then the other one kind of has to sit on top. But when you try to sit these on top of one another, they're kind of awkward. They don't really kind of sit on one another properly, so that's kind of strange. But again, this is a different design. So obviously the first thing we want to do is try it out, which I've done. I just connected a signal generator, and just looking at the output, it's very nice and clean. But like I said, some of the knobs, you can see if I move them how noisy they are. So those are definitely going to need cleaned, which is no big deal. But everything else, and you can see I'm turning the bass and treble knobs right now. But other than that, I think this will be a fairly simple thing. So we'll kind of look through how it's designed inside. We'll maybe do a recap. I know several of you have asked me to show you how I replace capacitors. I've really shown that quite a few times on other videos, but some of those videos are getting pretty old, and if you don't kind of dig back through them, you may miss them. One thing I kind of wish I would have done, hindsight is always 20/20. I wish I would have done a little better job of labeling the videos, not just by what I'm working on, but like what things I covered in those videos, because each video I try to do something a little different that would help with all electronic service, you know, and that's one thing I didn't do. So probably need to do that one of these days, but I need to do a lot of things one of these days when I get the chance. Anyhow, let's get this apart and take a look at it. So we got it all taken apart, and really that's fairly straightforward. You on the back, you'll have two screws back here and here, and then this top cover just pops off. Then there's 4 screws here, and then 4 screws on the bottom, and then it's an L-shaped cover, just comes right off, and that exposes the bottom of the unit. And then the faceplate, after you take those bottom screws off, it also holds the bottom of the faceplate on. Then you take these two screws off. They're little black screws like this that are up here. Take them off, and the faceplate will come right off after you remove the knobs, of course. Now, a couple things I noticed when I got this apart, and that is, it doesn't look like it's going to be the easiest thing on earth to access anything if you need to replace something. These ones we can get out from the bottom, but anything up here is going to be kind of difficult. And although you can put some paper towel around here and kind of spray into here for cleaning the potentiometers, it's better if you could get in from the bottom. So it would be better to be able to get access to this. And also, if we decide we want to recap this, we're going to have to get these out. So unfortunately, you have a lot of wires in the way, and then you have to take all of these, the shaft mounting nuts off of the potentiometers and so forth, and then we can get the whole board out as an assembly to get in and work on it. So that's the only way to work on these, is to, you know, take it all apart. Now, these are pretty easy to clean over here. You take these 6 screws out, this faceplate will come off, and then you take a couple screws around this metal frame, this black aluminum frame, it comes off, and then you can get to those to clean them. And just looking around, I noticed that they're using these yellow Nichicon audio grade capacitors. These are an obsolete model of capacitor by Nichicon. And I think, but I'm not sure, I'm pretty sure though, that they were superseded by the fine gold, or the FG series, which, let me see if I can take one out here. They look kind of like this. They're like that gold color. And those would be a suitable replacement for these. So let's start talking a little bit about capacitors, which I've done this ad nauseum in other videos, but since I haven't done it in a while and people are starting to ask questions about it again, I thought I would go back through and review some of this. So the first thing you want to know is that there are different capacitors designed for different applications. There's always people that come on to the comments section and tell you, you know, a capacitor is a capacitor. As long as the microfarads and the voltage is the same, it doesn't matter. You're wasting your money. And I disagree with that personally. Now, I do think that sometimes people get exploited by some of these boutique companies, because I think there is a physical limit to, you know, what a capacitor does. But as long as it's designed for the application that you're using it for, that's really all we care about. So I'm going to try to make this a little bit easier. First of all, there are many companies that are very reputable, that have been around for a very long time, and they make very high quality components. The one I use the most is Nichicon. Another one that I use is Panasonic. I also like WIMA, W-I-M-A. I like Rubicon. I like Cornell Dubilier. There's quite a few out there that are good quality components, and they're well made. And each one of the manufacturers that I named, they have a whole series of different capacitors designed for different purposes. So we're going to use Nichicon as an example. If you go onto their website, and that's how you spell it, Nichicon, and I think you can go to .com or .jp or something, you can download their capacitor selection chart. And you can see each one of these little blue square boxes is a different series of capacitor, and you can see they have them broken down by application. This is really important. For those who think that, you know, just all you need is the microfarads and the voltage, and that's good enough. If you've ever put, you know, a low grade, you know, a line grade capacitor in a switch mode power supply, you will pretty shortly realize that there is a difference in capacitors. There's all kinds of things like ripple current, equivalent series resistance, temperature coefficient. There's many different things. So what these companies, and this is just one example, all of the manufacturers have this data sheet that you can download and print out. They all have application charts to help you to choose the correct brand or type of capacitor for what application you're going to use it in. So for instance, there's a whole section here with the little musical note, and these are all audio grade capacitors. Different ones are different quality. So for instance, the KT series, which are those blue ones, and you see me use those a lot in a lot of the equipment that I work on. And let's see if I have one I can just show you real quick. Here's one. So this, for instance, would be a KT series. See how it's blue? It says audio grade on it. Well, those are good because they're 105 degree. In other words, they can handle high temperatures better than the other ones. When you start getting into the Muse series, so that would be like the FG, and I believe the, what is it, KZ right here. Those capacitors are especially designed to be used in the audio path. So anything that your audio signal is going to pass through, you would want to use something like that, like your KZ or your FG series. And they have special characteristics where they perform in their most accurate range within the frequencies of the audio frequency range. So for, in our case, 20 hertz to 20 kilohertz. Other capacitors don't function when you increase the frequency above about 120 hertz. They really start to change their values rapidly. Why do I say 120 hertz? Well, if you take a 60 hertz signal out of your mains and you full wave rectify it, you will get a 120 pulse. It'll be like a halfway, it'll be a full wave rectified signal. So you'll have 120 pulses where it goes from 0 to your peak voltage to 0 again, 120 times per second. And then that capacitor's job is to filter that out. And those 120 pulses per second, it can handle. But as soon as you start feeding higher frequencies through it, the capacitors become less efficient unless they're designed for that. So for instance, with a switch mode power supply, like a power supply you'd see in your computer or something, those can have very, very high frequencies applied across them, in the range of, tens of kilohertz. And when you do that, some of those lower grade caps can't handle that. You have to have a capacitor that's especially designed for that. So if you look, some of these will say that they're good for switch mode power supplies. So the whole point that I'm making is that you do have to pick the correct capacitor. Anything in the audio path or in an audio amplifier, you want to stay in this box right here, with one exception, and I put this note here to remind myself when I did this. This KL series, if you have those funny looking orange capacitors, like in the Pioneer stereos, a lot of the high-end ones will have them. They're orange and they're like sealed on the bottom. They almost look like they have an acrylic epoxy in the bottom instead of like a rubber plug. And those are a very low leakage type capacitor, very special type of audio grade capacitor. And these are a perfect match for those, the KL series. Even though they're not listed up here in the audio grade, for that particular position, these are the best ones to use. Now you can use the KZ series and the FG series, and they would work in that place. But if you wanted to match the component to its original specs, this would be your closest one for that. So hopefully that gives you a little, I could do an entire video on capacitors and then some. because of all the different things that there is to know about them. But anyway, when we see these yellow ones here, in this case, these ones are going to be audio grade capacitors more than likely. These blue ones and these gray ones are typically going to be in a power application where they're filtering, noise out of the power supply or something. Same thing with these blue ones here. So kind of knowing what their application is will help you to choose the correct one for this. And by the way, capacitors kind of overlap with their applications. For instance, these KT series up here, they're kind of a good all-around capacitor. They will work very well in power supplies because they're 105 degree, meaning they have a higher temperature coefficient, which means when they're in a lower temperature environment, like room temperature, they will actually last a lot longer. They're more durable. They are audio grade, so they will work in the audio path, but not quite as well as these. The KZ and FGs, they actually, the way they're designed internally, they are somewhat shock mounted, I guess the way you put it. It's the way they put the capacitor inside the metal can. They're designed to reduce susceptance to vibration. So if you if there's any kind of vibration, it's not going to cause any kind of noise in the capacitor, as much as maybe some other grades of capacitors may be susceptible to that. So all those things are just things to think about. Anyway, enough of that. Let's talk about replacing them and how we replace them. There are many different methods for recapping an amplifier and changing the capacitors out. But the main goal that we have is leave no traces behind that you were in there, other than the capacitors are different. And what I mean by that is when you flip this thing over, you can see all the little solder pads on there. And some of them can get pretty small. So if we look, kind of get at an angle here, you can actually see how tiny and thin some of these little tracks are in here. And I can tell you, if you put your soldering iron on there at too high a temperature and you leave it on there for too long, this will actually come unbonded from the substrate. So the fiber circuit board, this copper trace, will literally just delaminate. And then once that happens, it's very, very thin copper. This little loop here, the little pad they call it, will snap right off. Then you have problems. Then you're doing things like you're scraping this track off here and bending a lead over and soldering it. And my goal is to never do that unless I absolutely have to. You have to be careful. Now, if you have the proper equipment to do this, it's a pretty straightforward process. So for instance, in my case, I have one of these. This is a commercial grade desoldering station, and it goes with a modular base that you can kind of see over here, down here, that controls it, and it very, very accurately controls the temperature, it controls the vacuum, all these things, and it actually will heat up the solder all the way around the pad, and then when I squeeze the trigger, a little vacuum pump turns on, and it'll actually suck the solder right through that hollow tip and right into this little container. And it's a very fast process, so you don't have to have the hot soldering tip on there for too long to minimize the risk of damaging those pads. Now, if you don't have that sort of thing, it's not the end of the world. You can use simple techniques. For instance, you can just take your soldering iron and you can just kind of touch it to the component and then just kind of rock it out, like heat it up and kind of rock one half back a little bit, then heat the other part, rock it back, and come back and forth, and you can pull it out. And then you can use a little bit of desoldering braid, which, let's see if I have some handy. which is this stuff. And all this is copper braiding. And some of them come with some flux in them. Some of them you have to put flux on it. And I recommend, you know, taking a little bit of flux, like from your flux pen or a little something like that, put on to this, and then you can actually use this and it'll kind of soak up the excess solder and clean the area. But again, this is abrasive, and if your dwell time is too long on there, you'll heat up the pad and you can actually tear it or damage it. So you got to be very careful working with this. Another option would be to use a solder sucker. So here's a little tiny handheld one, and all it is a little vacuum pump. So there's a spring in there and there's a little plunger in here, and when you push the little button, it just pulls a vacuum there and it sucks the solder up inside here, and then you push it back out through. And they make larger ones. Here's one right here. This is like a big plastic handheld one. This has a lot more power to it. But that's another thing you could do. So you would heat up the joint, and then you would go on here and then just pop it right out. So different methods. And the main key to all of this is not to overheat or to stay on that joint too long. And if you're going to invest in anything for electronics, you know, where you're going to work on this, one of your best investments is a temperature controlled soldering iron. So for instance, I have this other one up here. This one can control up to 3 devices, and then this one will only control 1 device. And this is the model, the Hakko FX951, but they also make the FX, what is it, 888 or 888 or something like that. That's actually quite affordable. There are also some lower grade ones that can be had for, you know, I did a video on one that was, you know, it was like $30 or $40. It was a very nice, it worked out very well. I gave it away. And make sure you get a temperature controlled iron. That way, and there's even that T100, the one that runs on the, you know, it's like a little all-in-one self-contained, and you just use a little laptop computer power supply to run it. Those are nice. Something, though, that you can control the tip temperature so that it doesn't overheat the pad. That's really what we care about. So with that in mind, we'll get everything fired up and we'll replace one of these caps. I'll kind of go through the process with you and show you. Okay, let's do some recapping now. So I'm going to show you 3 different methods, going from the little bit more difficult way to the less difficult way, let's just say. So the first way we're going to do is we're just going to heat the joint up and rock it out. So we're going to replace this little 10 microfarad capacitor back here, and you can see the negative terminal is on this side and the positive's on this side. And if you look at the board on this particular unit, it's marked down there. There's a little minus sign. I don't know if you can see that or not, but if you look very carefully, and I don't have to move the camera too much, you can see it right there, that little minus. So the board is properly marked. If it's not, and if you're forgetful, you may want to mark where everything is so you don't forget, or take some pictures. But if you're just doing one cap at a time and you remember how they came out, you shouldn't have a problem. So to remove this, it takes a little bit of dexterity, but you only need your soldering iron and your fingers to do this. So I'm going to try to do this around the camera. It's easier when you don't have a camera in the way. So down here is the 2 terminals for the capacitor, and we're going to heat the first side up, and then we're just going to rock it back a little bit. Then we're going to go to the other one and we're going to rock the capacitor with our finger the other direction. And we're just going to go back and forth very quickly. You don't want to stay on there too long. And you can see it pops right out. It's just like pulling a tooth. The idea is not, did you notice I never stayed on either one of those terminals for very long? Now, if you don't have solder braid or anything like that, you know, like this stuff, then what you can do is reverse the process. You take your new capacitor, put it in the hole there, you know, down in here, and then you just heat each side up and rock it back in. So let's do that. Let me find a 10 microfarad capacitor. All right, let's see here. It needs 10 at 50, correct? So there's a 10 at 50 right there. And you notice the new ones are a lot smaller than the old ones. And what I'm going to do is I'm going to shorten these leads a little bit so I don't have to push them down so far. Just kind of nip them down. And then since this is has a little bit wider lead spacing, I'm just going to take this a little bit and just kind of bend it out a little bit like that, make a letter Y, and then we're going to just kind of move them up like that, and that just makes them a little closer to the same width. So now what you want to do is we're going to, and I'll try to keep this in frame so you can see it. So we're going to line up our minus with our minus again. And if you notice, if I try to push that back in right now, it won't go. And that's because the solder is still blocking the pad there, because we didn't remove the solder, we just made it soft so that we can remove the capacitor. So in this case, what we're going to do is we're going to just heat up each side again and rock it back in a little bit at a time. I don't know, let me get my finger out of the way. And you can see slowly but surely it goes back in. Now, if you did it correctly, it should look fairly clean. Like you have a hard time telling where we worked. And it was actually right here and here, these two right here and here. Okay? And if the leads are too long, you can kind of just snip them off. Now, if the solder joint didn't turn out super shiny like that, you can do one of two things. You can take a little bit of solder and just add a little bit of solder. This is so hard around this camera to hold everything. So you would just add a little bit of solder like this, just a tiny bit, and just see how quick I was on and off of there. Or you can put just a little dab of flux there if you have, although I don't like to use flux all the time because it's messy and you have to clean it. If you don't have to clean it, but it kind of bothers me if it's not cleaned off. So there you go. Now that's method number one. Another way would be to use one of these, a desoldering pump. And we'll do another one of these. Here's another one of these 10 at 50s right here. And we're going to flip it over. And we can see once again, there it is. And I will try to keep this in frame around the camera as best I can and hold everything. So when we're ready, we're going to heat it up. This is really awkward. There's one. And there's two. And that's all there is to it. And it's actually easier if you don't have a camera in your way. So And of course I removed the resistor and not the capacitor. Well, I showed you how to remove a resistor. How's that, guys? All right. So let's put that back in. We'll fix that in a second. It's kind of like reminds me of the saying, you know, measure twice, cut once. Well, now you get to see me do this again with my other hand. Let's see if I can get in here. All right. Awkward as an ostrich in a porta potty, as they say. And then it should come right out. Yep, that one's loose. This one here's, I didn't quite get it. Yeah, it's loose. Okay, so let's pop that one out. And the nice thing about this one is if you use a desoldering pump like that, it allows you to just push the new cap right in, and you don't have to worry about heating the joint up and rocking it back in and all that sort of stuff. And I probably should have got another capacitor out while I was at it, huh? So here's another one. And once again, we're going to just kind of nip some of this down a little bit. And then we're going to, again, we're going to make our Y. Just like that. Make sure your minus is lined up. And you can see this time the thing went right in. And to help hold it, you can flare them out just a little bit if you like. Sometimes you have to do that, especially when you're working around a camera. And let's see what we can do here. All right. And of course it pulled out a little bit. And then there, and let's put our resistor back in. That was a bonus lesson there, how to take a resistor out. Okay, so that's method number 2. Now for method number 3, we're going to use this desoldering wick. Now, chem wick is a very good, this is probably one of the best ones on the market, although you can also get just generic desolder braid and it works also. And this you can sometimes get away with just using it as is out of the spool, but honestly the best way to use this stuff is if you have some of this liquid flux. When I say liquid, it's this really runny stuff, and if you have to cut it a little bit with alcohol or something to make it thinner, it's better that way. And I usually will take this and I'll just put a little dab just like this and let it soak down in there, and it really works. Wait till you see how good it works like that. So get our soldering iron around our camera. Let's see if we can take another resistor out first. What do you think? Okay, so here we go. And the problem, one of the things with this stuff is your dwell time is going to be a little longer. In other words, you're going to have this on the joint a little longer than normal. So if this is an old hand-taped circuit board, like the really old ones, I don't recommend using this because you stay on there a little bit too long, and you can actually lift the tracks. But if you look at this, if I would stay on the camera here, if you look down here, you can kind of see just how clean that gets with that solder braid like that. It just totally cleans it off. So that's another good way to do it. And then we just pull the tooth. And this is a 1 microfarad at 50 volts. And again, these aren't signal path capacitors here. So we're just using good quality standard capacitors. Okay. So here's another nice, here's a 1 microfarad at 50 volts. And notice it's the same size as the 10 microfarad as far as the case is concerned. So we'll pop that in there. And this one you can actually just put in as is, just like the one that came out. Make sure your minus is lined up once again in the right connector. And then just bend these over a little bit. Give them a little snip. Just like that. And we'll get some fresh solder. And see if we can do this without making too much of a mess. That's it. And there you have it. And if you did it correctly, number one, it should not be shaped like a dome. It should be shaped more like a cone. Do you see how the solder is kind of shaped like a cone on all these? And it should be very shiny. There should be no little inclusions or anything, or occlusions on it, however you want to word it. And that's a good solder joint. That'll hold up. Okay, so that's method number 3. Okay, last but not least is the most expensive method, because you actually have to have some rather expensive equipment to do this. What we're going to use is we're going to actually use a desoldering gun, actually a desoldering station. And what we're going to do is we're going to replace this 10 microfarad at 470 microfarad at 10 volts with this 470 at 16 volts. Now, it's okay to go a little bit higher in voltage. You never ever go lower in voltage, but it's okay to go a little bit higher. What it's not okay to do is go way higher. I would not put a 470 volts or 470 microfarad at 63 volts in there. Why is that? Well, believe it or not, the voltage rating of the capacitor can affect how the capacitor operates. So when it's not operating at its near, at least above 50% of its operating voltage, sometimes certain versions of these caps will not perform properly. Capacitors are rated at capacitances like this. Like this one says 470 microfarads, but what you'll find out is that can change depending upon what kind of ripple current and frequency you're applying across the capacitor. So you really, it's really not a big price difference between this one and say one at 63 volts, for instance. And so really the main reason they do this is to make sure that the capacitor performs at its rating, so that it's not running outside of its tolerances. So again, you can go a little bit bigger, like this is 16 volt instead of 10 volt. I would never put a 63 volt or 100 volt. Part of the other problem is the capacitors have a hard time staying formed. In other words, there's an electrochemical reaction taking place inside of these electrolytic capacitors, and they actually need voltage across them to stay capacitors, if that makes sense. And if you don't apply enough voltage to them, they will actually drift in value and start to develop a high ESR, or equivalent series resistance. So capacitors are a science all in of theirself, and so there's a lot more than I can really talk about in this video, but just the takeaway from this is it's okay to go a little bit higher in voltage. Even if you'd put maybe a 25 volt in here, it would probably be okay, but 10, 12, or 16 volt here would all be good, is in my opinion. So anyway, we're going to use this now. And again, like I said, this has a little vacuum hose connected to it, and there's a little catch tank here for the solder. And then this is hollow on the end, you can see. We're going to clean the tip a little bit. And this is very slick. You basically go on there. That's that one. Done. Simple as that. It pops right out. Perfectly clean. Take our new one. Make sure we get the minus lined up again, correct? Pop that in there. Bend the leads out a little bit so it doesn't fall out. Little clip. And solder it in. Now, you don't have to buy an expensive name brand desoldering station like a Pace or a JBC or Hacko or Weller or whatever. These are great for heavy use if you do this sort of stuff for a living, but they're really not necessary. There are a lot of lower cost ones that you can buy on Amazon and eBay and all the normal haunts, and you're still going to spend some money on a pump desoldering gun like this. Expect to spend at least in the neighborhood of $70 to $100 even for like a Chinese one. But they do work. I had one for a very long, probably 10 years I used it, and I ended up giving it to one of my employees, and he's still using it today. So you don't necessarily have to spend a lot of money to get one that'll work for what you do. Again, if you're going to do this for a living, these ones hold up a lot better, and they have more options on them. But I'll leave that up to you. But anyway, that's how I do a recap, and you can see with that gun you can go pretty fast. So I'm going to go through and do the rest of these, and I'm going to put this thing back together and we'll try it out. So the recap is all done, everything's put back together, and really the only last thing to do is check the voltage, which I've already done. There's two power supply adjustments in here. There's this R501 up here, and then this pot down here, and then you check these three test points here and these three test points here, and you just make sure that you have a plus and minus 35 volts or 33 volts, positive and negative 33 volts, and one pot adjusts them both. So this one pot adjusts positive and negative together. Same thing down here. I didn't have to adjust them. They were exactly on. So everything was good, and we're ready to put this thing together and test it. Well, it seems like we have another mystery here. I got it all put together, it's recapped, everything's good. And the funny thing is, I can connect this to a signal generator and to the oscilloscope, and I can run this all the way down from just a few millivolts of a sine wave, 1 kilohertz sine wave, all the way up to about 10 or 12 volts RMS. And absolutely perfectly undistorted signal. But as soon as I connect actual music to it, the music sounds completely distorted, almost like an amplifier that has one of the output transistors of a complementary push-pull pair, one of the transistors blown or something. That real kind of sound, and it's both channels. And it kind of fades in and out. It's very strange, and it's not voltage related. So this is going to be really interesting. Now, the first thing we have to determine is, do we have a power problem, which it doesn't look to be? Did I install a capacitor incorrectly? Just so you know, I did a visual check of all the capacitors on both boards, and they all look perfect. So I couldn't visually see anything wrong. Or, and I also checked the values; they're all good. And the strange thing is, this is a dual mono design to the point where the left channel and right channel are on two separate circuit boards. So for both channels to both be doing the same thing, and the funny thing is they both have differing levels of distortion between them. And they even kind of have separate power supplies to a degree, although they share the main power transformer. So this is going to be a really interesting thing to try to troubleshoot now. So what was going to turn out to be a put it back together real quick and get it off the bench is now turning into, we're going to have to figure out what's going on. And it doesn't look like it's something I'm just going to be able to feed a sine wave into it and find it, because it only seems to do it when there's music, for what that's worth. So stay tuned. So I tried one of the Mitsubishi amplifiers and it did it. And I know it's not the amplifier 100%, but just to rule it out for you and for me, I broke out the old Carver M500. I know it's perfect. By the way, on the other amplifier, the Mitsubishi, I was able to feed the signal directly from the computer into the amp, and it was crystal clear. So it's definitely up here. And I'm going to hold the microphone by one of the speakers, and I'm going to turn this up so you can actually hear what it sounds like. I have some YouTube audio library music just to give you an idea of how it sounds. Hear how it's kind of like crackly and distorted, and it's just really not normal. I mean, that's not what we would expect. And again, if you just feed a pure sine wave into it, it doesn't seem to be a problem. It's only when there's a complex waveform like music going through it. So which kind of inclines me to believe that it's something related to a capacitor or something like that. And both channels seem to do it. If I turn this one up and I turn this one down, it's the same kind of thing. Again, I can hear it. It's distorted. It's not pure and clean. It doesn't sound like if you're bypassing the amplifier. And I have the tone defeats on. It doesn't matter if they're not on. It has nothing to do with the tone control. So, something strange. So we're going to have to dig into this and see what it is. Alright, so after poking around with this for a while, it turns out that this muting relay is bad. And if I turn this up a little bit, and it makes sense because it's common to both channels, and if I wiggle this around enough, it'll, there. Hear how it pops in? There it goes. It's bad. And it just so happens that that is the exact same relay that was in the Sansui AUX1. And I popped the cover off here just to look at it. And you can't really tell if they're bad. They just go bad. But you can see it's that exact same relay. It's the one that has the coil contacts here and the common contacts back here. They're swapped around from a standard relay, so that makes it really difficult, if not impossible, to replace without modifying it. So what we're going to try to do is, it's going to be a hack job, but we are going to move these tracks around. We'll put in a modern replacement, and we will put this back together, and that should fix our problem. Well, there it is. Let's see if that fixed our problem. Yep, all fixed. It's amazing what these little relays will do when they go bad. They wear out. I mean, they're mechanical things. Expect it to happen. So luckily that's all it was, and we didn't have to dig too deep into the rest of it. I was kind of skeptical that it would be anything electronic, as far as transistors and things, because it was doing it on both channels. So there's not a whole lot that in this dual mono quote-unquote amplifier that would be common to both channels. So it made sense. So there you have it. That's all it was, and let's put it back together again. Okay, we're all plugged back in, and of course we're listening to this through my lapel microphone, but you'll get the point. It's working. Sounds like something from Pulp Fiction, doesn't it? And I have the tone defeated right now. Now the only thing that I don't like is these are those knurled shafts like that. They have those little ridges. And if these aren't glued in there properly, you can't really adjust it. You can only put it in to the nearest tooth. So if I can put it this way, or I can put it this way, but either way, you can't make it perfectly line up on the numbers, and that's just the way those knurled. I really like the ones with the set screws a little better. And since these pots are direct soldered to the board, you can't rotate them, so they're going to be just off a little bit. I guess that's the way it is. But this thing's working really well, and it sounds really good. I can tell you when you put these two pieces together, it's huge. It is actually physically larger than, it's, as far as the depth goes, it's even bigger than that SX 1980 that we did. You can see it kind of goes all the way back on the bench. But it's a neat unit, and unfortunately, I was going to do something here. I'll show you something else. Give me a second. The last piece that we have here, let me put this mic back on, is a Mitsubishi DA P20. It's essentially this exact preamp. I mean, the circuit is identical, and they added a tuner to it. And it's really not a super high-end tuner. It's a good tuner, but it's mid-range for this era. It's totally analog. It does not have synthesized tuning or anything like that. So it's really basic. And really, if we would have done any video on this, it would have been redundant as far as the preamp section is concerned, and really the only difference would be maybe doing an alignment on the tuner. But we have a lot of tuner projects coming up. So being that the owner is coming today, I have this down to the wire. This repair just couldn't have happened any sooner. That's all we're going to be able to do, so I'm not going to be able to do this one. It is working perfectly. It really doesn't need restored. It was relatively clean. It had some dust in it I cleaned out, but testing it all out, everything was good. I mean, even the pots were good. They weren't dirty. I mean, I cleaned them, did a little bit of shot of deoxit on them, but this thing works really well. The other unfortunate thing is there are some aftermarket speaker terminals that I was going to replace on all of the amplifiers that the owner ordered, and unfortunately they are taking forever to come in. So what I may do is when they come in, I may just forward them to him, and either he can install them. It's a relatively simple thing to replace them. If you can solder a wire onto a terminal, you can handle it, and because they're direct drop-in replacements. And maybe I'll just do a quick 5-minute video if they come in, just to show you what they look like, because they do make, the same company apparently makes aftermarket speaker terminals for all the different amplifiers, or many different amplifiers out there, I should say. So that wraps up this video, and as always, I'm going to wish you all peace, joy, happiness, and good health in your lives. We have a lot of things coming up, and so as I get time here, we'll be churning out the videos. So take care, everybody, and we'll see you soon. Bye-bye.